Okay, so this video is going to take a look at solving these out by various techniques here. And in this first one that we got for these natural logs, it looks like a pretty straightforward one. So if I just have one natural log right here, what I want to do is I want to get that isolated out. So to do so, I'm going to subtract 3 from each side and just do some very simple algebra here. Okay, and that is going to give me 7.25 on this side. And then I'm going to divide by 4. And so after I do that, I'm going to get the natural log of 7 divided by 4 is... All right, that guy right there. I should have said 7.25 divided by 4. So now we got this number right here, and we want to take it out as many decimals as we can to improve our accuracy. So we are going to then take a look at, let's see, we're going to use this property, which is the definition of a log, to knock this thing out. And we've done this before. So basically we got this base e, and we say e to this power equals x. So I'm going to go x equals e to the 1.8125 power, okay, which is the exact solution, okay, because we know that e is irrational. And if we put it into a calculator, it's going to unpack it and make a bunch of decimals. But let's see what this approximately is here. So let's ask our calculator. Okay, so taking this out to 3 decimal places, I'm going to go 6.126, okay, and this is our approximate. Now, we just need to check our solutions, okay? So, can't have the log of a negative number, and when I look to see, put this on in here, is it going to give me the log of a negative number? And the answer is no, it's not. And so therefore, I know that that solution is going to work. And so that's how you do that guy. Okay, so let's take a look at the next example. Okay, this one has a little bit of stuff going on with it. And there's a couple different ways to do this, but I want to reiterate this property here that sometimes we lose sight of, is that if I'm going to have a square root sign under here, the square root is like raising whatever that the radicand to the 1/2 power. So I'm going to do that and see if I can get this 1/2 power out in front here using this property right here, the power rule, right? And so this 1/2 power is going to come out in front, and we're going to rewrite this as the natural log, and we got that 1/2 in front of x plus 2 equals 2. And let's multiply each side by 2 in order to get rid of this fraction right here. And so this is going to give me, I don't know why I drew a line there, silly, natural log of x plus 2 equals 4. So now we're going to roll into the definition of a log because we have the natural log all by itself. And so we will go e to the 4th equals x plus 2. So x plus 2 equals e to the 4th. And now I want to subtract 2 on each side, and we get x equals e to the 4th minus 2. And this is, again, going to be our exact solution. Consulting our calculator, this is what it's going to give us. All right, so x is approximately, out to 3 decimal places, 52.598, and this is the approximate. Okay, so that's how you do that guy, and let's take a look at another one. Okay, it looks like this guy's got a lot going on here. And so first thing that I want to do is that I'm thinking, since we got a lot of natural logs on both sides, we might be able to set up this 1-to-1 property here. And we like that property because it makes things a lot easier. We don't have to use the definition of a log, and we can skip right to the algebra. So going left to right here, I'm going to take advantage of this plus sign here. And I got two logs that are being added, so I'm going to make those into a product. And I also have this guy right here that I'm going to pop up there using the power rule. And so let's rewrite this as the natural log of, and now I have x minus 2 times 2x minus 3 equals the natural log of x to the second. Okay, so now I can get rid of the logs, okay, because I have one natural log on this side, one natural log on this side, and so let's get rid of them. And now I have x minus 2 times 2x minus 3 equals x to the second. So now I got to do some algebra. So let's FOIL out this guy right here and see if we can get a quadratic going, so we might be able to factor, use the quadratic formula or something like that. So we'd get 2x squared minus 3x minus 4x plus 6 equals x squared. Okay. Collecting the like terms, I get 2x squared minus 7x plus 6 equals x squared. So now, as we learned in the past, we need, if we're going to solve a quadratic, we need it equal to 0. And so what we're going to do is that we're going to, let's subtract this x squared from each side here. And that will give us what we want. So I got 2x squared minus x squared. That's going to give me just an x squared minus 7x plus 6 equals 0. Okay, so now we can solve this out by using this method. What two numbers are going to multiply to 6 and add to a negative 7? So it looks like it's going to be a negative 1 and a, let's see, negative 6. That'll work, right? So negative 1 times the negative 6 is 6, and negative 1 plus the negative 6 is 7. I think that's a winner. And so now we have this guy, just like so. And we learned earlier on in the year that we could set each one of those equal to 0, and using the zero product property, and solve from there. So I got x equals 1 and x equals 6. Okay, so now here's and please pay very close attention, okay? These are both positive numbers. These are both positive solutions. However, look up here at the x minus 2 and the 2x minus 3 and the x. If I plug either one of those solutions in, the 1 or the 6, and that leaves me with a negative number, I have to get rid of it, okay? So starting right here, and this one, and I'm going to put it in this color right here. Okay, the x plus 1. If I put 1s in here, notice that this is going to be 1 minus 2. That's a negative. And this is a negative here. And so I have to go ahead and say that this is not a solution, because I plugged it in and that gave me a negative number. So when I try the 6 right here, that's going to, 6 minus 2, that's positive. Okay, that's going to be 12 minus 3. That's positive, and the 6 is positive. So it looks like my only solution is going to be x equals 6. Okay, so you got to plug it in and see if it's going to give you a negative number. If it is, you have to get rid of it. Okay, so last example is going to be one that you see a little bit in higher mathematics. And it is this guy right here. So e to the ln x power is just x. So that means is that if you have e and it's raised to the ln power, everything in here can just come out in front. So we would get 3x minus 7 equals 2. And then, of course, we're going to add 7 to each side. And we got some some easy algebra in front of us here. So we got 9 divided by 3, and x is 3. Okay. So we plug it back in, making sure that this is not going to give us a negative number. So I got 3 times 3, which is going to give me 9 minus 7, which is 2. So we're good. Okay. So that is kind of like a a smattering of different problems that you might run into. So what you want to do is take a look at the assignment, give them a try. Don't forget to check your answers, and have a go with it. And I will see you in the next video.